Welcome to the DIY Honda Garage channel. DTC P0068 refers to a throttle position correlation issue specifically associated with the Honda Civic model ranges from 2016 to 2021. This diagnostic trouble code DTC arises when discrepancies in the signals from throttle position sensors occur, leading to potential performance and drivability problems. The throttle position sensor plays a critical role in monitoring the position of the throttle plate inside the throttle body, which regulates air intake into the engine. If this correlation is inadequate, it can trigger the vehicle's engine management system to flag an issue. This presentation will delve into the specific components involved, possible causes of the error, symptoms that may arise, and structured troubleshooting steps to effectively isolate and rectify the fault. The throttle position correlation DTC P0068 indicates a confirmed fault relating to the throttle position sensor. This sensor's primary role is to monitor the angle of the throttle valve located within the throttle body, which is crucial for controlling the engine's air intake. If there's any misalignment in sensor readings, the Engine Control Module, ECM, will register a fault. No pending DTC is applicable here, signifying that this trouble code needs immediate attention for resolution. The throttle body is typically found between the air intake and the engine and is integral for maintaining optimal performance. Thorough examination of this component is vital, as any obstructions, damage, or sensor failures can lead to this fault. Several potential causes lead to the P0068 throttle position correlation error in the Honda Civic models mentioned. Sludge or carbon accumulation on the throttle valve may impede functionality, affecting signal accuracy from the throttle position sensor. Additionally, faulty connectors or terminal issues can disrupt communication between the sensors and the Engine Control Module, ECM, leading to discrepancies in throttle input readings. Faulty sensors, particularly the manifold absolute pressure MAP sensor and turbocharger boost sensor, can also contribute to erroneous data input, triggering this DTC. Therefore, a thorough inspection of these components is essential to pinpoint the root cause effectively. ECM connections should also be scrutinized, since loose or corroded connections at this level might lead to intermittent issues. Drivers may experience several symptoms that clearly indicate DTC P0068's presence. The most common symptom is illumination of the check engine light, often regarding performance-related issues. Drivers might also notice reduced engine performance, particularly when accelerating or climbing hills, which can make the vehicle feel sluggish. Irregular acceleration patterns can manifest, whereby the vehicle might surge forward or fail to respond while the throttle position is adjusted. In some cases, stalling can occur as a result of the engine not receiving the correct air-fuel mixture. Thus, if any of these symptoms arise, it is crucial to investigate the throttle position correlation issue promptly to prevent further complications. In troubleshooting step 1, begin by turning the vehicle to the off, lock mode to ensure all electrical systems are inactive, preventing potential injury or damage. Following this, disconnect the throttle body inlet pipe as well as the throttle body connector tube from the throttle body to gain access for inspection. Once disassembled, carefully inspect the throttle valve to check for any sludge or carbon buildup, which can severely obstruct throttle function. This step is critical, as contaminants can disrupt sensor function, leading to erroneous readings. If any sludge or carbon is detected, it is imperative to clean the throttle body meticulously before proceeding to the next step. If no buildup is found, it indicates that the issue lies elsewhere, warranting further troubleshooting. In this second troubleshooting step, reconnect the throttle body inlet pipe and the throttle body connector tube systematically, ensuring all connections are snugly fitted. Next, utilize the Honda Diagnostic System, HDS, to record all relevant onboard snapshots, which capture vital engine parameters and conditions during operation. After documenting these readings, turn the vehicle to the on mode to enable diagnostics without starting the engine. Clear the existing DTC with the HDS before cranking the engine. Once the engine is running, conduct a driving test for several minutes, focusing on the recorded snapshot parameters, such as engine speed and vehicle speed. This data will help differentiate between confirmed and pending DTCs, essential for accurate fault isolation. Step 3 focuses on checking signal parameter differences using HDS after turning the vehicle to the off lock mode and then to on again. During this sequence, systematically examine the readings of the barometric barosensor, turbocharger TC boost pressure, and the manifold absolute pressure MAP sensor for high-resolution outputs. This evaluation aims to identify discrepancies in sensor readings, which are pivotal for diagnosing the throttle position correlation issue. Specifically, assess the differences in values and categorize them into specific patterns as outlined in the relevant diagnostic tables. The results help determine whether to advance to further steps, depending on whether the patterns observed align with the diagnostic criteria. In this fourth troubleshooting step, you'll substitute the manifold absolute pressure MAP sensor / IAT intake air temperature sensor with a known good unit to validate functionality. It is essential to ensure all connectors are securely reattached during this procedure, since loose connections can create misleading results. After ensuring all parts are reconnected, turn the vehicle to the on mode and clear the DTC via the HDS diagnostics tool. Starting the engine afterwards is crucial, as it enables monitoring of system performance to see if the issue persists under operational conditions. Again, test drive the vehicle and check for any pending or confirmed DTCs that emerge during this period to determine the next course of action. The fifth troubleshooting step involves substituting the turbocharger boost sensor with a known good replacement to ascertain whether this component is at fault. As before, confirm that all connectors are effectively reattached to avoid any errant signals during testing. After establishing secure connections, transition the vehicle into the on mode and clear the DTC using the HDS. Starting the engine following this ensures a proper check of the newly installed sensor's performance. A test drive is also necessary to observe the behavior of the vehicle, particularly in monitoring if DTC P0068 is indicated once more. If the issue continues, it further implies that the earlier suspected component is functioning well, leading to the recommendation of checking or replacing the MAP sensor, IAT sensor 2, and possibly the throttle body itself. Final repair verification is crucial following the completion of the troubleshooting steps. Initially, check for any remaining diagnostic trouble codes, DTCs, to ascertain whether any underlying issues persist even after the remedial actions taken. If additional codes are logged, they should be meticulously reviewed to guide further action effectively. Clear all DTCs once satisfied that repairs are complete, ensuring a clean slate for the vehicle's computer system. Afterward, take the vehicle for a test drive under various conditions to confirm that performance issues have been resolved. Observing responsiveness during acceleration and monitoring for normal operating conditions will help validate the effectiveness of the repair. Preventive maintenance plays a vital role in averting future occurrences of DTC P0068. Regular cleaning of the throttle body is paramount, as this prevents sludge and carbon buildup that could hinder sensor readings and throttle function. It's advisable to incorporate throttle body inspections during routine service checks, allowing any potential obstructions or contaminants to be addressed. Furthermore, inspecting connectors and ensuring they're secured can significantly reduce the risk of faults due to poor connections or corrosion. Lastly, maintain awareness of vehicle performance and any signs of drivability issues, enabling swift action if symptoms reappear. Implementing these practices will prolong the lifespan of the throttle body and associated sensors. In conclusion, understanding DTC P0068's implications not only helps in effective troubleshooting, but also aids in preventing future occurrences. Following the systematic troubleshooting steps laid out ensures comprehensive checks on all related components, ultimately isolating the fault effectively. Recognizing the significance of the throttle position sensor and its correlation with other sensors is paramount for overall vehicle performance. Ultimately, by performing regular preventive maintenance and being aware of signs that indicate system disturbances, vehicle owners can ensure long-term reliability and performance of their Honda Civic. This knowledge empowers owners and technicians alike to act efficiently in maintaining the integrity of the vehicle's operation. Please like and subscribe to the channel. See you next time.